Calculus students, this is the video of the retake information for sections 5.1 through 5.3. And like it says, a reminder, you had to have all that homework in from sections 5.1 through 5.3, including the reviews, in order to be eligible to retake the test. If you didn't do that, then you can stop the video right now. Number one, watch this video and take notes of everything as I go through this. All work shown. As I talk about the distance learning test, write down the problem, write down what we did so that you can use that to study by. And number two, go back in your notes, highlight the problems that would be similar to the test problems that were chosen. Number three, you have to redo the review assignment again, and that was a packet. It can be found in the black folder on Schoology if you want to print that one out again. So redo the review assignment, take your time and make sure you understand the concepts, show the details. That was the biggest problem with this one, and we did have spring break in here before we tested, but it was pretty obvious that a lot of people didn't even take a look at their pre-calculus over spring break, and you just cannot do that with a college in the schools class. You have to keep up with what's going on. Number four, the distance learners, because you're going to have to show me all this stuff that you finished up. You need to send your video flipping through all the things that you did to go through the retake process by April 21st at 2:45 p.m. with number 1 through 3 above completed. No exceptions. In the video, make sure you flip through everything. You tell me what it was that you did. And here are the notes from the video. Here are the highlighted notes. You know, all of those things as you go through it. And I'll check off that list to make sure that everything's been completed. And you need to do that, and you need to put time into it. If you don't, the retake is going to be just as bad as the first time through. So this information that I'm giving you, it needs to be something that's a process for you, not something that you run through, or it's just going to be worse when you take your test the second time. You have to put time into learning this material and understanding it. Face-to-face students, you can just show me all of your work by the 21st at 2:45. And then for everybody, the deadline for actually taking this test is going to be the 22nd. So you should contact me ahead of time, and we'll get some arrangements made here, whether or not you need me to watch you take it in a Google Meet or not. For distance learners, face-to-face students, you are required to take a paper test in school, which would be after school, because that's really when you have enough time to go through the test and do a good job on it. So now, here is the test before we changed it, because this was in a multiple choice format. But I'm just telling you this because again, this is the distance learners test. It was not a multiple choice test. And I just want you to know that this is what the problems were, in case you have to, pause the video and come back here to write the problem down. If when we get to my work for this, since there wasn't room right here, I had to write work on paper. You can always come back here to see exactly what those problems were as we went through it. So I will scroll down a bit and give you a little pause here in case you need to come back to this and write it down. Again, the purpose here is just to give you time enough to write the problem down. The distance learners did not have a multiple choice version of this test. They had to show all of their work just like all of you did in face-to-face. All right. So here we go. Number one said, find the tangent of theta if the secant of theta is the square root of 10 over 3 and the sine of theta is less than 0. So pretty obviously they're trying to tell us what quadrant they're in, since secant is positive and sine is going to be negative. So you think, okay, secant, that's what you get when you flip cosine. So cosine has to be positive and sine has to be negative, and that's going to be in the fourth quadrant. So that means that tangent in the fourth quadrant, what we're trying to find, is going to have to be negative. And the directions for these said use the fundamental identities to find the value of the trigonometric function. So you had to use these Pythagorean identities down here to figure out what was going on. This was not go back and use the old Pythagorean theorem like we have been doing when we first started trig. We now have identities to use for this. So since they gave us tangent, we should be using 1 plus tangent squared theta equals secant squared theta. We substitute the value for secant theta in and square it. And the square root of 10 over 3 squared will be 10/9. Then you subtract 1 from both sides, and you get 1/9. And then you have tangent squared, so you have to take the square root of both sides. Square root of 1 is 1, square root of 9 is 3, and then again we knew it was in quadrant 4, so that made it negative, so negative 1/3. Number 2 was given that the tangent of theta minus pi over 2 equals negative 0.4. Find the cotangent of theta, again using fundamental identities. And this is the cofunction identity, and I had warned you beforehand that this is one of the things that first-year trig students miss. That is backwards. It should be pi over 2 minus theta, because cofunctions are complementary. To find one, you should take 90 degrees minus the angle that you do have to find its cofunction. So you flip that around, and obviously you'd have to factor a negative out to do that. And tangent, we cannot drop the negative. It is not even. We have to keep it. So once we get to this point, we see the tangent of pi over 2 minus theta. Well, the cofunction for tangent is cotangent. So you substitute cotangent in, and you realize, well, they gave me cotangent. It's negative 0.4. So all I have to do to get cotangent alone is divide both sides by negative 1, and I'll have cotangent. So any problem like this that's using the cofunctions has to get us thinking, okay, it's sine and cosine, secant and cosecant, tangent and cotangent that are cofunctions. Their names tell us what they're doing. Then number 3, the instructions were use basic identities to simplify the expression. Again, these are the identities that we've just learned. So cotangent, again, is a secondary function, probably not so obvious to everybody. Becomes really easy if you make cotangent cosine over sine, and then you make secant 1 over cosine, and you can see that cosine will cancel out, sine will cancel out, and you will get 1. Number 4 had the same instructions. So 1 over cotangent squared, you should think, oh, that's how they write reciprocals. What's the reciprocal of cotangent squared? Well, it's tangent squared. And then for secant and cosine, some of you were able to immediately go to 1 because you remembered those were reciprocals. But when I made the key for the test here, I did what I did with the homework, which was try to put things in terms of the primary trig functions, and in particular sine and cosine, so that everybody could see, if they were struggling with these problems, how to get the right answer. So when we have 1 over cosine times cosine over 1, which is secant times cosine, we get 1. And then we see tangent squared plus 1, and here's where I know some people were doing some serious overthinking, because you totally missed the fact that that comes from one of our Pythagorean identities right there. And you can't just know sine squared plus cosine squared equals 1. You have to be able to use the other two as well after you derive those from sine squared theta plus cosine squared theta equals 1. Number 5, the direction said simplify the expression. So with this one, most people notice, hey, sine squared x plus cosine squared x, that's 1. Most people noticed that right away. But then again, there were some people that did not recognize the cosecant squared x minus cotangent squared x, because notice if we just subtracted cotangent squared theta from both sides of the identity, well, then we would have 1. So if you saw those things, this was a very short problem, because all you had to do was 1 minus 1 equals 0. It was more likely that people did what I wrote down up here so that they could figure out that it was going to be 0. So most people noticed cosecant squared and said, oh, that's 1 plus cotangent squared. And then you distribute the negative, so we have 1 minus cotangent squared x plus cotangent squared x. And of course, everything by subtraction there is going to drop out, and you're going to get a 0. Number 6, this one had the same instructions. You had to simplify the expression. Again, breaking this down to see cosine and sine. So cotangent is cosine over sine times sine of x over 1. And then the cofunction of sine of pi over 2 minus x is going to be cosine of x. Well, then you see that negative cosine of x plus cosine of x, that's 0. that's just going to drop out. And if you do a little bit of canceling here with the sine of x and the sine of x, all that you're left with is cosine of x. And that's what we needed to do to simplify that to a single trig function. Number 7, this one also just said simplify the expression. So again, could have been a very, very quick and easy problem. If you noticed, cosine squared x plus sine squared x is 1, and cotangent squared x minus cosecant squared x, well, you'd have to move the 1 over to the other side, and that would be a negative 1. So it could have been a very basic problem of 1 divided by negative 1 equals negative 1. But again, not a lot of people noticed that. People did notice the cosine squared x plus sine squared x on the top for a 1. And then in the denominator often did what I have here, which is substituting in for either the cotangent squared or the cosecant squared x, and did manage to make their way to the negative 1 as well. I should tell you that normally this test, I see a lot of 50 points out of 50 points or 51 out of 50 points. I did have about 6 people in first and second hour that managed that, but again, way too many people that didn't look over their pre-calculus over spring break, and that is just a disaster waiting to happen. All right, number 8. This one definitely takes some more work to simplify the expression. Now, again, you're going to see this is kind of the long way here because I changed everything into cosine and sine, but you can get to the correct answer, and that's what I saw the bulk of students that did this correctly were doing this math right here. So cotangent of x becomes cosine of x over sine of x. Secant squared of x becomes 1 over cosine squared of x. And then cotangent is cosine of x over sine of x, and cosecant squared x is 1 over sine squared x. Now, I wanted to see what does that simplify to, because I see cosine of x within one fraction, and I see sine of x and sine squared of x within one fraction. So maybe it simplifies to something that would be a little bit easier to work with. So I went ahead and multiplied by the reciprocals, and sure enough, I got something that immediately said, kind of screams, hey, take a cosine out of the numerator. So factor a cosine of x out of the numerator, and we see cosine squared x plus sine squared x. And of course, that tells us that we have a 1 there. And then we end up with cosine of x over sine of x, which is, of course, cotangent of x. So even though it might look like it's really step intensive, it's some basic work with cosine and sine that gets you there. Number 9, the directions change. It says write each expression in factored form as an algebraic expression of a single trigonometric function. I saw 2 ways of doing this, but the way that I have up there is the most common way that I saw people doing this work, and that would be substituting in for sine squared of x from the Pythagorean identity. And when you do that and you distribute correctly, because there were some people that did this step wrong right here, you'll get a negative 1 plus cosine squared x, and then you go ahead and put it in standard form, which has the squared first, and then the cosine of x in the middle, minus 2. And you just factor that because you're looking for 2 numbers that multiply to negative 2 and add to 1. Pretty quickly you can get the plus 2 and the minus 1. And what that was supposed to help you think about was what we started doing in number 10, which was finding all the solutions in the interval from 0 to 2 pi. So just once around for these. And for number 10, hopefully, you see, oh, I could have just factored out a sine of x there and then set it equal to 0. So sine of x equals 0 at 0 and pi. Remember from the unit circle that what we're looking for is a 0 in the y position in order to have the sine of x equal 0. So that's at 0 and at pi. And then we have the sine of x plus 1 equals 0, and that means that the sine of x has to equal negative 1, and there's only one position that has the y value as negative 1, and that's going to be 3 pi over 2. So again, number 9 was to get you ready for factoring, which is exactly what you should have done with number 11. Just factor that into 2 sine of x minus 1, the quantity squared. And the fact that it's squared doesn't matter, because if we take the square root of both sides, we're still going to get a 0 on the right-hand side. Then you'd add 1 and divide by 2, and we need to know where the sine of x equals 1/2. So sine of x is opposite over hypotenuse, And if the 1 is opposite, that means we're talking about a 30-degree angle. And it has to be a positive 1/2, so that's first and second quadrant where sine is positive. So our 30-degree angle would be pi over 6. And in second quadrant, with our 30-degree angle as our reference angle, it would be 5 pi over 6. Down to number 12, the directions changed to determine if the following is an identity. So obviously I had to see your math here to know that you knew what you were doing. Most people said, hey, cotangent squared x, if I use a Pythagorean identity, that'll get me, in fact, right here, cosine squared x minus 1, and cosine squared x minus 1 does factor to cosine of squared x minus 1 times the quantity cosecant of x plus 1. The other way I saw people do this was to start with the right-hand side, which in fact that's what I did over here, which was taking cosecant x minus 1 times cosecant x plus 1, because that's our sum and difference formula. That gives you cosecant squared x minus 1, and then you use the Pythagorean identity and get cotangent squared of x. And yes, that means it works because that was the other side. Now, number 13 takes some more work to get to that part. So we have 1 plus cosecant x over secant. Does that equal cosine of x plus cotangent of x? Oh, nope, on this version of the test it was a minus cotangent of x. So I started with the left-hand side, and I separated this into 1 over secant of x plus cosecant over secant of x. And that's cosine of x, and then I went with the sine and the cosine in order to see what was going on as far as cosecant divided by secant, and that meant multiplying by the reciprocal. And that gave me cosine of x plus cosine of x over sine of x, which is, of course, cotangent x. But that's plus, and your problem said minus, so no, it didn't work. We did not get subtraction for cosine of x minus cotangent of x. Number 14. Number 14, most people just went ahead and got a common denominator, which is really the fast and smart way to go with this one. When you see you have the sum and difference pattern down there on the bottom, and we're always looking for squareds because we want to use those Pythagorean identities. So you end up with 1 minus sine of x plus 1 plus sine of x over 1 minus sine squared x. And of course 1 plus 1 is 2, and negative sine of x plus sine of x is 0. Those two drop out. So you have 2 over 1 minus the sine squared of x, and hopefully your brain said, oh, that's cosine squared x, because that's from a Pythagorean identity. And then having the cosine squared x in the denominator means we're talking about secant squared. So 2 secant squared x. Now, it was pretty typical if somebody messed up on 15 and 16 with find an exact value, that it was usually negative signs. You know, you missed a sign here. And those formulas were part of the test. So you just have to slow down a little bit and make sure you're writing the formulas down right. Because you needed the sine of 30 degrees and the cosine of 45 degrees. And the sine of 30 degrees is 1/2. Cosine of 45 degrees is the square root of 2 over 2. Then you needed the cosine of 30 degrees, which is the square root of 3 over 2. And sine of 45, which is the square root of 2 over 2. And whether or not you drew your triangles or you used, you know, the little first quadrant of the unit circle made no difference. You'd get the right answers. You just had to be careful. And like I said, it was usually negative signs if somebody messed up on these. And there were a lot of negatives to keep track of in, oh, that's as far up as it can go, huh? There, that one's a little better. Now, on the review, when we had the tangent of something with a negative in it, a lot of you chose to factor out the negative and put it in front. And I saw probably 2 or 3 people from both classes that did that on this test and just went ahead and put the negative out in front. But there was a person that then forgot to add it back on at the end of the problem. So that's always the danger. So this one I just went ahead and kept it as the tangent of negative pi over 4 plus negative pi over 3, because that would give us our negative 7/12, and just worked in, the different quadrants. Instead of working in first quadrant, working in fourth quadrant, which meant there were a lot of negatives to keep track of. But again, the danger is always you'll forget the negative if you don't do that. So the other thing I saw was some people were figuring out tangent wrong. Usually it was for the 60-degree angle, the negative 60-degree angle that it happened for. Negative mistakes. Yeah, those were the most common things that I saw that were wrong with number 16. Because there were a lot of different ways that people went after that one, and all of them, if you got it wrong, usually involved a negative. One or two people messed up what the tangent of negative pi over 3 would be when they went through there. So that is the distance learner test. The retake for this it's a little bit longer, but again, I really think that the two problems with this were people didn't look over their pre-calc over spring break, which bad idea. Second, seriously overthinking. I mean, some of these problems, like I had mentioned earlier, where you could just make things 1 and -1 right away, people had a half a page for these problems, and you just need to constantly be thinking whenever you see a squared, hey, I've got an opportunity to use the Pythagorean identities here. I should be using those, because that's what we're supposed to do with this test, If you look at the directions, it said use the fundamental identities to find the value of the trigonometric function, use basic identities to simplify the expression. So it's those types of things that whenever you see a squared, you have to think, wait a minute, I can probably do something with my Pythagorean identities here. Now, there's the dates again. So all remedial work done by end of school day, April 21st, and then the deadline for taking that retake would be on the 22nd, which is a Thursday. So a Wednesday and a Thursday for getting that work in, and then retaking the test. Good luck.